Before you fall asleep tonight, consider this quietly surprising thought. The universe is not cooling all at once. Some places are still holding warmth from the beginning of time, while others have already begun to fade. There may be regions where new universes could one day be born, even as ours slowly grows still. The cosmos remembers its first moment, and somehow, you are part of that memory. So settle in, slow your breath, and let the universe tell you one last story before sleep takes over. Welcome. You've found your way to a quiet corner of the night. Maybe today felt long. Or maybe you simply enjoy drifting off while your thoughts wander through stars and distant places. Either way, you don't need to do anything now. Just allow your body to soften, your breathing to slow, and your attention to gently loosen its grip. Tonight, we'll be moving through the universe itself. Not rushing. Not searching for answers. Just touching calm ideas one by one, letting them pass like slow-moving clouds. We'll glide through ancient light, wandering planets, strange stars, and mysteries that don't demand to be solved. Some thoughts may linger. Others may fade before you notice. And that's perfectly fine. If this space brings you rest, you're welcome to stay connected. But for now, simply listen, and begin wherever your mind feels most comfortable. The universe may be older than we think. For a long time, scientists have estimated the universe to be about 13.8 billion years old. This number comes from studying the faint glow left over from the early universe and how quickly space itself is expanding. Yet, not all measurements agree. Some ancient stars appear older than they should be. Some galaxies seem too mature for such a young cosmos. Others suggest the expansion of the universe may not be as constant as we once believed. Most astronomers still accept the familiar number. But the quiet question remains. What if the beginning we imagine was only one chapter in a much longer story? Lonely planets drift without suns. Not every planet belongs to a star. Some travel alone. These wandering worlds move silently through space, untethered to any sun. Many were likely born in ordinary solar systems before being flung away by gravitational chaos. Others may have formed in isolation, never warmed by starlight at all. They are cold, dark, and nearly invisible. Only faint heat or brief alignments reveal their presence. There may be billions of them in our galaxy alone. Each one is a quiet sphere turning endlessly through darkness. No sunrise. No sunset. Only distant stars passing slowly overhead. The universe may repeat itself. We often imagine a universe with a single beginning and a long, quiet end. But some theories suggest a gentler rhythm. In these ideas, the universe expands, slows, collapses, and begins again. Not once, but endlessly. Each cycle may erase what came before, yet leave behind faint traces, like echoes too soft to hear. No final ending. No true beginning. Just motion, pause, and renewal across stretches of time too vast to measure. The oldest light still surrounds you. In the earliest moments, the universe was thick with heat and energy. Light could not travel freely. Then, about 380,000 years after everything began, space cooled enough for atoms to form. The fog cleared. Light was released. That ancient glow still fills the universe today. Stretched thin by time and distance, it hums quietly in microwaves. It isn't light from stars. It's light from the universe itself, remembering the moment it first became transparent. Some planets may be made of crystal. In rare conditions, planets can form in carbon-rich environments. With enough pressure, that carbon may crystallize. At least one such world has been identified. a dense planet circling the remains of a dead star. Its interior may be composed largely of diamond-like structures. It wouldn't sparkle like a gem. The heat would be intense. But deep below the surface, immense crystalline lattices could stretch for thousands of kilometers. Stone worlds, gas worlds, and sometimes crystal ones. Space may have no edge at all. It's natural to imagine space ending somewhere, a final boundary. But according to our best understanding, space doesn't end. It curves. Like walking around Earth, you could travel forever without reaching an edge. Always moving forward. Eventually returning. Not by turning around, but by following the shape of space itself. The universe may not be infinite in size, but infinite in journey. Our sun may have been born with a sibling. Many stars are born in pairs. Some astronomers believe our sun once had a twin. Formed from the same cloud, this sibling star may have drifted away billions of years ago, pulled apart by the slow movement of the galaxy. If it still exists, it now travels a separate path through the Milky Way. The sun shines alone in our sky, but its beginning may have been shared. Neutron stars compress reality itself. When massive stars collapse, they can leave behind something extraordinary. A neutron star, only a few kilometers wide, yet heavier than the sun. Matter packed so tightly that atoms are crushed into near pure density. A droplet of this material would outweigh mountains. Inside, matter behaves more like a fluid of gravity than anything familiar. Small, dark, spinning, a quiet monument to collapse. Light can arrive more than once. Gravity bends space, and space bends light. In regions of intense gravity, light from distant galaxies can split and curve, reaching us along different paths. The result is duplication. Arcs, rings, multiple images of the same object. In rare cases, the same stellar explosion has been seen more than once, arriving at different times along different routes. Light wandering, getting delayed, and still finding its way. The first stars burned fiercely and briefly. The earliest stars were massive and short-lived, made almost entirely of hydrogen and helium. They burned intensely, far brighter than our sun, and they died young. Their explosions forged the first heavy elements. Without them, planets, chemistry, and life itself would not exist. Their light is gone, but their influence remains everywhere. Dark matter passes through you right now. As you rest, unseen particles move through your body, not interacting, not leaving a trace. Dark matter surrounds our galaxy in a vast halo. And as Earth travels through it, countless particles pass through you every second. You never feel them. But without them, galaxies would unravel. Invisible, essential, always present. Some galaxies barely glow at all. Not all galaxies blaze with stars. Some drift quietly, filled with gas and dark matter, yet almost no light. They challenge what we thought galaxies needed to exist. Why they remain dim is still unclear. They move silently through space. Forgotten, unanswered. A strange cold place in the early universe. In the faint glow of the universe's earliest light, one region stands out. Colder than expected. Vast. Unexplained. Some think it's a massive void. Others wonder if it hints at something even stranger. It doesn't shout. It whispers. The moon is slowly letting go. Each year, the moon drifts a little farther away. Just a few centimeters. Long ago, it was much closer. Days were shorter. Tides stronger. This slow separation will continue for billions of years. Quiet. Steady. Unstoppable. Some stars exchange themselves. In close binary systems, stars can grow so near that they share matter. Gas flows from one to the other in glowing spirals. Sometimes the exchange is gentle, sometimes violent. Two stars turning together, reshaping each other in silence. Their paths are quietly linked. Some of the universe's most unusual events, rare supernovae, tightly bound neutron star pairs, begin as these gentle, touching systems. Two stars growing close enough to share their outer layers. A reminder that even in the vastness of space, change can happen through closeness, exchange, and quiet connection. Empty space is never truly empty. What we call emptiness is alive with motion. Even far from stars and galaxies, the vacuum of space is restless. According to quantum physics, tiny pairs of particles briefly appear and disappear everywhere, all the time. They flicker in and out of existence so quickly that we never see them directly. Yet their presence matters. These fluctuations influence forces, affect fields, and contribute to the background energy of space itself. They are part of what we call dark energy, the unseen influence driving the universe's expansion. So when we imagine deep space as silent and still, that picture is incomplete. Beneath the quiet lies constant motion, a soft hum of possibility woven into the fabric of nothing. Time does not flow the same everywhere. We experience time as steady and reliable. But in the universe, time bends. Near massive objects, black holes, dense clusters, time slows compared to regions of weaker gravity. This isn't just theory. It's been measured by clocks and satellites. Some scientists wonder if time may vary even more subtly across the cosmos. Could different regions experience slightly different rates of time because of how the universe expanded long ago? The idea remains uncertain, but it reminds us that time is not a universal drumbeat. It stretches and softens, shaped by space itself. The Milky Way is wrapped in something unseen. The glowing spiral we recognize is only part of our galaxy. Surrounding it is a vast halo, a sphere of dark matter and thin gas extending far beyond the visible stars. This halo holds ancient star clusters, wandering stars, and enormous amounts of unseen mass. We don't see it directly. We sense it through gravity, through the way stars move and light bends. The Milky Way is not just a spiral of light. It is the bright center of something far larger. A luminous core wrapped in invisible structure. We can see a galaxy from the universe's infancy. Light takes time to travel. So when we look far into space, we look backward. Using powerful telescopes, astronomers have detected light from a galaxy that existed only about 200 million years after the Big Bang. That light has traveled for more than 13 billion years to reach us. The galaxy is small and faint, but it carries clues about how the first stars and structures formed. It is a quiet glimpse into a time when darkness was just beginning to lift, when the universe was learning how to shine. The universe resembles a vast web. When galaxies are mapped across enormous distances, patterns emerge. They gather along long filaments, leaving wide empty spaces between them. This structure, known as the cosmic web, stretches across billions of light years. Strangely, when viewed from afar, it resembles the networks found in the human brain. Dense clusters like nodes, filaments like connections. The resemblance is visual, not conscious. But it is quietly poetic. Two systems, governed by different laws, shaped into similar forms. Stars vibrate in silent rhythms. Space carries no sound. Yet stars still tremble. Inside them, pressure waves move through hot gases, causing subtle pulsations. Scientists detect these vibrations by observing tiny changes in brightness and motion. This study is called astroseismology, the listening of stars. Each star has its own pattern, shaped by its size, age, and internal structure. Through these silent rhythms, we learn what lies beneath a star's surface. A form of listening without sound. A quiet music written in light. Some stars are older than the galaxies they inhabit. Galaxies grow over time. They merge, absorb smaller systems, and rearrange themselves. Because of this, some stars formed long before the galaxy around them took its present shape. These ancient stars often live in distant clusters or far from galactic centers. Many are nearly as old as the universe itself. They contain fewer heavy elements, formed in a simpler cosmic era. They are stellar fossils. Still shining. Still carrying memories from the universe's earliest days. A few galaxies seem to lack dark matter. Dark matter is thought to be essential. The invisible glue holding galaxies together. Yet some galaxies appear to behave as if it isn't there. Their stars move as though only visible matter exists. This discovery surprised astronomers. It doesn't fit neatly into existing models. Perhaps dark matter was stripped away. Perhaps our understanding is incomplete. Either way, these galaxies remind us that the universe still resists certainty. The sun resonates like a living instrument. Deep within the sun, pressure waves ripple through hot plasma. They bounce, reflect, and set the entire star into gentle vibration. Scientists study these motions through helioseismology. By observing how the sun subtly pulses, they map its interior, its density, rotation, and hidden flows. The sun is always vibrating, always resonating. A vast, complex instrument playing endlessly. Galaxies move along invisible highways. The largest structures in the universe are shaped by dark matter. Over time, it formed enormous filaments stretching across space. Galaxies gather along these filaments, moving like beads on unseen threads. Between them lie immense voids, nearly empty regions of space. The visible universe rests on this hidden framework. We still don't know what dark matter is, but its influence is everywhere. Space itself can expand faster than light. Nothing can move through space faster than light. But space itself can stretch without limit. In the universe's earliest moments, expansion separated regions faster than light could cross between them. Even today, distant galaxies recede not because they are moving quickly, but because space is growing between us. Some regions are now beyond our reach forever, carried away by expansion we cannot follow. The universe doesn't rush. It simply unfolds. Our solar system traces a spiral through the galaxy. The planets orbit the sun. But the sun itself is moving. As it travels around the Milky Way, the planets follow behind, creating a spiraling path through space. A slow, graceful corkscrew motion. Nothing is still. Not planets. Not stars. Not galaxies. Even as you sleep, you are moving through layers of motion within motion. Even emptiness has warmth. Deep space feels cold. But it is not temperatureless. Everywhere in the universe, faint radiation remains from the Big Bang. This cosmic background sets the temperature of empty space at just above absolute zero. It is the lingering warmth of creation itself. A gentle echo that has never fully faded. Tiny quantum ripples shaped everything. At the smallest scales, reality flickers with uncertainty. Energy briefly appears and disappears. During the universe's earliest moments, these tiny fluctuations were stretched by rapid expansion. They became the seeds of galaxies, stars, and cosmic structure. What we see today may trace back to momentary tremors in nothingness. The largest patterns born from the smallest chances. Some dying stars pulse like slow hearts. Not all stars end abruptly. Some enter a final phase of rhythmic expansion and contraction. They brighten and dim over regular cycles, days, months, or years. These variable stars act as cosmic clocks. Their steady pulses help astronomers measure vast distances. They fade slowly, breathing in and out, marking time across millions of years. They remind us that even as stars fade, they can still mark time. Not with ticking seconds, but with slow, patient breaths stretched across eternity. Earth drifts inside a quiet bubble of ancient fire. If your eyes could sense wavelengths beyond sight, you would see that our solar system floats inside a vast hollow of glowing gas. This region is known as the local bubble. It spans hundreds of light years and was shaped long before Earth existed. Ancient supernovae, stars ending their lives in violent explosions, swept through this region, heating and clearing the surrounding gas. What remains is a low-density chamber, calm and gentle now. We move through it silently, unaware. A peaceful neighborhood born from ancient destruction, softened by time. A pull from mass and a push from emptiness. There is a region of space known as the Great Attractor. An enormous concentration of mass drawing entire clusters of galaxies, including our own, slowly toward it. But beyond that pull lies something just as powerful in its own way. A vast cosmic void, often called the Dipole repeller. It is not dense. It is almost empty. And that emptiness seems to push galaxies away. Together, attraction and absence shape the flow of our local universe. In space, not only matter guides motion. Even emptiness has influence. Invisible travelers pass through you every moment. Right now, countless particles are moving through your body without notice. They are called neutrinos. Born in the sun, in distant supernovae, and in the early universe itself, neutrinos rarely interact with anything. They pass through planets, oceans, and people as if nothing were there. Most never leave a trace. They are nearly massless, nearly untouchable. And yet they fill the universe with motion. Proof that stillness is often an illusion. Some stars vanish without a farewell. We often imagine a massive star ending in brilliant explosion. But for the largest stars, the end can be strangely quiet. In a process known as direct collapse, gravity overwhelms everything at once. The core caves inward. The outer layers follow. No bright supernova. No final blaze. Just absence. Astronomers have observed stars that simply disappear from the sky. Light gone. Matter folded into darkness. Not every ending announces itself. Some fade without sound. Galaxies can keep companions. Galaxies are rarely alone. Many large galaxies are surrounded by smaller companions, drifting in long, slow orbits. The Milky Way itself hosts dozens. These smaller galaxies move like moons, tracing vast elliptical paths over billions of years. Sometimes stars are pulled away, forming delicate streams across space. Eventually, a companion may dissolve entirely into its host. A quiet merging, measured not in moments, but in cosmic ages. Even galaxies, it seems, prefer company. The universe's brightest flashes come from magnetic collapse. Among the most powerful explosions known are those linked to magnetars. Ultra-dense neutron stars wrapped in magnetic fields trillions of times stronger than Earth's. When a massive star collapses into a magnetar, the release of energy can be extraordinary. Brief flashes of gamma rays that outshine entire galaxies for seconds. These events are rare, short-lived, and visible across billions of light years. Intensity born from something impossibly small and dense. The edge we see is not the edge that exists. There is a limit to how far we can observe. Light beyond a certain distance simply hasn't had time to reach us. This boundary is called the observable universe. Not a wall, not an ending, just the edge of visibility. Beyond it, space almost certainly continues. With more stars, more galaxies, possibly without end. Reality is larger than what light has shown us so far. Some galaxies launch streams across intergalactic space. At the hearts of many galaxies sit supermassive black holes. And sometimes, matter falling toward them is redirected. Powerful magnetic fields funnel material outward in narrow jets, blasting plasma at near light speed. These jets can stretch millions of light years into space. They carve enormous shapes visible only in radio light. Vast signatures left by invisible engines. Even regions ruled by darkness can leave lasting marks. A star that swims against the galactic flow. Most stars orbit the Milky Way in the same direction. But not all. At least one known star travels backward, its orbit cutting against the galaxy's rotation. Perhaps it came from another galaxy long ago. Perhaps it was flung into its path by a gravitational encounter. Whatever the cause, it moves differently. A reminder that even in cosmic systems, not everything follows the pattern. The galaxy's center carries familiar chemistry. Near the Milky Way's core, astronomers have identified complex organic molecules, including one associated on Earth with raspberries and rum. Space has no scent, but chemistry travels everywhere. Sugars, alcohols, molecular precursors to life. Not life itself, but the ingredients drifting quietly between stars. A distant meeting already underway. The Andromeda Galaxy is moving toward us. Slowly, inevitably. Though the visible collision is billions of years away, the outer halos of both galaxies already overlap. Their invisible envelopes have begun to touch. When they finally merge, stars will mostly pass unharmed. Two spirals blending into one larger form. A cosmic encounter unfolding patiently across time. The universe still glows around you. Everywhere you are, space is filled with ancient light. The cosmic microwave background. Released when the universe was young enough to finally let light travel freely. That glow has been stretching ever since. Now it surrounds you faintly, silently. A whisper from the universe's childhood. The oldest light we can ever see. Some stellar deaths are hidden, not bright. Not every supernova shines. In some cases, a star collapses so completely that its energy is swallowed before light can escape. A failed supernova. Astronomers have watched stars vanish without explosion. No flare. No glow. Just disappearance. Violence concealed by gravity itself. Some galaxies barely shine at all. Not all galaxies glow brightly. Some contain few stars, yet still possess mass, gas and dark matter shaping their form. They are faint, elusive, and hard to detect. They exist quietly, gravitationally present, but visually subtle. Proof that existence does not always announce itself with light. Black holes can merge without sound. When two black holes orbit one another, they slowly lose energy. Their paths tighten. Eventually, they collide. No flash. No explosion. Instead, space itself ripples. Gravitational waves spreading outward at light speed. We can detect these ripples from Earth. Echoes of invisible giants becoming one. For a brief moment, the universe vibrates. Some stars fade over billions of years. Stars like our Sun do not explode. They age gently. They expand, shed their outer layers, and leave behind dense cores called white dwarfs. These remnants glow quietly, cooling over billions of years. No drama. No collapse. Just a slow release of warmth into darkness. A final, patient goodbye. A future that has not arrived yet. One day, white dwarfs will cool completely. They will become black dwarfs, cold, dark remnants of once living stars. But the universe is still too young for that ending. Not a single black dwarf exists yet. Every white dwarf that has ever formed is still glowing faintly somewhere, slowly releasing its last warmth into space. Their deaths are not sudden. They are like embers, cooling patiently over unimaginable spans of time. Time bends near darkness. Gravity does more than pull. It reshapes time itself. According to general relativity, the stronger the gravity, the slower time flows. Near a black hole, this effect becomes extreme. If you were to hover just outside the event horizon, your minutes could equal years for someone far away. Your clock would fall behind the universe. This isn't science fiction. It's a measurable effect known as gravitational time dilation. Black holes don't just trap light. They stretch time, thinning it like fabric drawn too tight. The coldest places imaginable. Between galaxies lies a vast, near-perfect stillness. No stars. No planets. Almost no matter at all. In these regions, temperatures fall to just above absolute zero, about 2.7 Kelvin. Colder than any natural environment on Earth. Colder than most laboratories can achieve. This cold comes from absence. With almost nothing to hold energy, heat simply slips away. These intergalactic voids are the universe's quietest places. Endless, empty, and filled only with the faint afterglow of creation. Darkness has become clearer over time. The early universe was once opaque. Light could not travel freely. Space was filled with a hot fog of particles that scattered photons endlessly. But as the universe expanded and cooled, electrons joined with nuclei, forming neutral atoms. Suddenly, light was free. This moment, called recombination, released the cosmic microwave background we still detect today. Since then, the universe has grown steadily more transparent. Matter spread thinner. Obstacles faded. What was once bright and cloudy has become dark and clear. A shadow captured at last. In 2019, humanity saw something extraordinary. Not a black hole itself, but its shadow. At the center of the galaxy M87, 53 million light-years away, a supermassive black hole revealed its presence through absence. A dark circle, surrounded by a glowing ring of heated gas. This image required telescopes across the entire Earth, working together as a single eye. Years of patience. Global cooperation. The result was more than a picture. It was proof that even the darkest objects can be studied through the light they distort. A galaxy visible to the naked eye. Most galaxies are unreachable to human sight alone. But one is close enough. On clear, moonless nights, the Andromeda galaxy appears as a faint, misty glow in the sky. No telescope required. Its light began traveling toward you over 2 million years ago. Long before cities. Long before humans. You can look up and see an entire galaxy, vast, ancient, and slowly approaching ours. A whisper detected on Earth. In 2015, a faint signal passed through our planet. So subtle it altered space by less than the width of a proton. It came from two black holes colliding more than 1 billion light-years away. Detected by instruments called LIGO, these gravitational waves confirmed a prediction Einstein made a century earlier. Space itself can ripple. We now listen to the universe. Not with ears, but with delicate machines sensing the soft echoes of invisible giants. Some places are leaving forever. The universe is expanding. And that expansion is accelerating. Some galaxies are being carried away so quickly that their light will never reach us. They have crossed a cosmic horizon. They still exist. But they are gone from view. Over billions of years, more of the universe will fade from sight. Not disappearing, just slipping beyond reach. The cosmos grows and quietly lets go. Black holes older than stars. Not all black holes need stars to be born. Some may have formed in the universe's first moments, tiny regions where gravity collapsed matter directly after the Big Bang. These are called primordial black holes. They could be ancient relics, older than galaxies themselves. We've never seen one directly. But if they exist, they may help explain dark matter or the earliest structure of the cosmos. Silent fossils from time's beginning. Invisible connections across space. Quantum entanglement links particles in ways that defy intuition. Two particles can remain connected no matter how far apart they drift. Change one, and the other responds instantly. Not through communication, but through shared reality. Some physicists wonder if entanglement plays a role in holding space itself together. Perhaps particles born together in the early universe remain linked even now. Invisible threads stretching across cosmic distances. Quiet connections woven into the fabric of existence. Even emptiness has pressure. A perfect vacuum does not exist. Even in empty space, quantum fluctuations stir. Particles appear and vanish. Fields tremble slightly. This restless energy creates vacuum pressure. On cosmic scales, it may be responsible for dark energy, the force accelerating the universe's expansion. Unlike matter, vacuum energy doesn't thin out as space grows. The more space there is, the more powerful it becomes. Nothingness, it seems, can push everything apart. Black holes slowly fade. Black holes are not eternal. Through a process called Hawking radiation, they lose energy incredibly slowly. Particles escape from the edge of the event horizon. For a black hole the mass of the Sun, this evaporation would take longer than trillions upon trillions of years. No explosion. No collapse. Just a slow, silent fading into nothing. Plasma fills the universe. Most matter in the universe is not solid, liquid, or gas. It is plasma. Ionized particles flowing freely, shaped by magnetic fields and electric currents. Stars are made of it. So is the space between galaxies. On Earth, plasma is rare. In space, it is everywhere. Glowing, moving, shaping the cosmos in ways we rarely notice. Ripples that travel at light speed. Gravitational waves move at the speed of light. They stretch and compress space as they pass. Born from collisions of massive objects, they carry information across the universe. About mass, motion, and warped space. They are gentle, almost imperceptible, yet real. Soft vibrations in the deep structure of reality. The universe is woven. On the largest scales, galaxies form patterns. Not random, but connected. They trace filaments of dark matter, forming a vast cosmic web. Clusters at intersections. Immense voids between. It resembles foam, or neural networks, or something grown rather than designed. This is the shape of the universe itself. Telescopes as time machines. The James Webb Space Telescope looks farther than ever before, and farther back in time. Some galaxies it observes no longer exist as they appear. They may have merged, transformed, or vanished. Yet their light continues to arrive. Every deep image is a gallery of the past. Frozen moments still traveling through space. Ancient light reaches you now. When you see distant galaxies, you are seeing history. Light that left before Earth formed, before the sun ignited. Some of that light has traveled for over 10 billion years. The stars that emitted it may be gone, but their glow endures. A reminder that the universe remembers, even when time has moved on. Their light lingers as a gentle reminder that the night sky carries stories far older than Earth itself. Galaxies can hide in plain sight. Even something as vast as a galaxy can disappear. In some regions of space, thick veils of interstellar dust drift between us and the light beyond. This dust isn't soft or fluffy, it's made of microscopic grains of carbon and silicate floating through cold molecular clouds. When a galaxy lies behind one of these clouds, its visible light can be dimmed or erased entirely. But look with different eyes, infrared, radio, or X-ray, and the galaxy slowly reappears. Astronomers have uncovered entire galaxies this way, hiding behind what once seemed like empty sky. In space, darkness doesn't always mean nothing is there. Sometimes it simply means the light hasn't found the right path yet. Perfect circles made of gravity. Sometimes, gravity bends light into symmetry. When a distant object lines up precisely behind a massive galaxy, the foreground gravity curves space-time just enough to wrap the background light into a perfect ring. This phenomenon is called an Einstein ring. These glowing circles are not created by motion, but by alignment, a quiet illusion shaped by gravity itself. The light may come from a distant galaxy, a quasar, or even a long-faded explosion. Einstein rings help astronomers weigh galaxies, trace dark matter, and peer into the early universe. They are natural lenses, silent, precise, and briefly perfect. A universe without edges. It's tempting to imagine a boundary, a final wall where the universe ends. But all evidence so far suggests space may stretch on without limit. We can only see a finite region, the observable universe, defined by how far light has had time to travel. Beyond that, space likely continues. No edge, no center, just more stars, more galaxies, more quiet distance. An infinite universe doesn't promise infinite answers. Only endless extension, a calm vastness without conclusion. Particles from distant catastrophes. Every second, particles from deep space strike Earth. These are cosmic rays, fragments of atoms accelerated to near-light speed by exploding stars, black holes, and violent cosmic events. Most are deflected by Earth's magnetic field or absorbed by the atmosphere. A few reach the surface. Some pass through you without notice. They are harmless reminders that space is not still. It is full of motion, energy, and messengers from distant places. Each cosmic ray carries a story that began light years away. There may be no before the Big Bang. We often ask what came before the Big Bang, but the question itself may be misplaced. In many cosmological models, time began with the Big Bang. Not just matter and energy, but time itself. Asking what came before is like asking what lies north of the North Pole. Some theories imagine earlier universes or strange quantum states. Others suggest that before simply has no meaning. The Big Bang wasn't an explosion in space. It was the beginning of space. Stars that weren't stars at all. When quasars were first discovered, astronomers thought they were nearby stars. They appeared small and point-like. but their light behaved strangely. Eventually, the truth emerged. These objects were unimaginably distant galaxies with ferociously active cores. At their centers lie supermassive black holes, surrounded by disks of infalling gas that glow brighter than entire galaxies. Their light traveled billions of years to reach us, yet arrived as a pinpoint. One of astronomy's greatest revelations began as a simple mistake. Drawn toward something unseen. The Milky Way is not stationary. Along with Andromeda and dozens of smaller galaxies, it drifts as part of the local group. And the local group itself is moving, pulled toward a massive gravitational region known as the Great Attractor. And beyond that, perhaps toward even larger structures still hidden behind the dense plane of our own galaxy. We can feel the pull, even if we can't yet see the source. Our cosmic neighborhood is sliding, slowly, towards something vast and obscured. The universe is in its stellar spring. There was a time when no stars existed at all. 400 millions of years after the Big Bang, the universe was dark. Then the first stars ignited. Since then, star formation rose, peaked, and has been declining ever since. We live in a cosmic spring, not the beginning, not the end, but a gentle middle. Stars still form. Light still spreads. And the universe remains bright enough to wonder, quiet enough to rest. When the lights begin to go out, star formation will not last forever. Galaxies will slowly exhaust their cold gas. Supernovae will scatter what remains. Radiation will heat the rest beyond usefulness. Over time, no new stars will be born. Existing stars will fade. First the giants, then the suns, then the smallest embers. The universe will not end suddenly. It will dim, gradually and gently. What remains will be remnants and silence. Most of reality is unseen. Everything you can see, stars, galaxies, glowing clouds, is only a small fraction of what exists. Most matter in the universe does not emit light. It is dark matter. We know it's there because of what it does, how galaxies rotate, how light bends, how clusters hold together. Dark matter forms an invisible scaffold, shaping the cosmos quietly from behind the scenes. We cannot see it, but without it, the universe would fall apart. Light stretched by time. As space expands, it stretches light itself. Photons traveling for billions of years are pulled into longer wavelengths. Visible light becomes infrared. This stretching, called redshift, allows astronomers to measure distance and age. With telescopes like James Webb, we can finally observe this ancient light, softened, reddened, and thinned by time. What began as brilliant starlight now arrives as a whisper. A holographic cosmos? Some physicists suggest that the universe may be a projection. That the three-dimensional world we experience could arise from information encoded on a distant boundary. This idea, the holographic principle, grew from studies of black holes, where information appears to live on surfaces rather than volumes. It remains unproven, but it reminds us that reality may be stranger than it feels. Solid things may emerge from deeper abstractions. Space itself may be grainy. At human scales, space feels smooth. But at the smallest imaginable lengths, the Planck scale, space may be discrete, pixelated, foamy. We have no direct way to test this yet. But if true, then everything unfolds not in a perfect void, but on a finely structured foundation beneath existence itself. Stars that spin impossibly fast. Some stars rotate with astonishing speed. Neutron stars, dense remnants of massive suns, can spin hundreds of times per second. Entire stars turning faster than kitchen blenders. These millisecond pulsars emit beams of radiation that sweep through space like cosmic lighthouses. They tick with remarkable precision. Ancient, dense, and impossibly fast. A quiet ending. The universe is not expected to collapse. Instead, it will continue expanding. Stars will fade. Black holes will evaporate. Matter itself may decay. Energy will spread thin until nothing meaningful happens anymore. This fate is called heat death. Not an explosion. Not a freeze. Just an endless, silent stillness. A universe that whispered itself into being and slowly whispers itself away. Galaxies that breathe. Some galaxies exhale. Powerful winds driven by star formation or active black holes can blow gas and dust outward for tens of thousands of light years. These galactic winds can shut down star formation and seed the cosmic web with heavy elements. A galaxy inhales matter, ignites stars, and exhales into space. The far future, a dark ocean. Trillions of years from now, galaxies will drift so far apart that each will appear alone. No new stars. No bright skies. Only cold remnants, black holes, and ancient light stretched thin. Eventually, even those remnants fade. What remains is motion without structure. A vast, dark ocean with no waves. Not an ending of drama, but of stillness. We may be drifting inside a vast cosmic hollow. The universe isn't evenly filled. Galaxies gather into filaments and clusters, leaving behind enormous regions of near emptiness known as cosmic voids. These quiet expanses stretch across hundreds of millions of light-years, holding only traces of matter. Some scientists suggest our own galaxy may rest inside one of these underdense regions. If so, certain mysteries, like subtle differences in the universe's expansion, might begin to make sense. Living inside a void wouldn't feel different to us. Life would go on unchanged. Yet it means that what feels like emptiness is actually part of a grand structure, the calm center of a cosmic bubble, floating gently within an unseen gravitational web. Some stars carry magnetic fields beyond imagination. Magnetars are the densest echoes of collapsed stars, neutron stars no larger than a city, yet wrapped in magnetic forces trillions of times stronger than Earth's. A compass bends to our planet's field. A magnetar's field could erase data from across the galaxy, distort atoms, even tear matter apart. These fields slowly fade, but while they last, magnetars release sudden flashes of high-energy light detectable across vast distances. They are brief, violent reminders of how extreme the universe can be, silent stars held together by memory and magnetism alone. The largest known structures in the universe may defy our expectations. Astronomers once discovered an immense chain of quasars stretching billions of light-years across space. So large that it challenges the idea that the universe should appear smooth on its grandest scales. These brilliant galactic cores seem connected, like distant lanterns aligned across cosmic darkness. Whether this structure is real or a rare coincidence remains debated. Either way, it suggests that the universe may weave patterns larger and stranger than our theories predict. Black holes reshape time into a one-way descent. A black hole doesn't merely swallow light. It bends space-time itself. As you approach its edge, space curves inward and time slows, almost to a standstill. Paths that once led forward become directions downward. Inside, all motion points toward the center, not through space, but through time. This isn't metaphor. It's geometry written by gravity, shaping reality into a funnel with no return. Some regions of the universe are already unreachable. Because cosmic expansion is accelerating, there are places drifting away faster than light could ever cross the gap. Their signals will never reach us, no matter how long we wait. Likewise, anything we send will never arrive there. Over time, galaxies will become isolated islands, surrounded by darkness. Nothing breaks the laws of physics. Space itself simply grows, quietly and relentlessly, separating one story from another forever. Gold was born in cosmic violence. This precious metal cannot form inside ordinary stars. It requires catastrophe. When neutron stars collide or rare supernovae erupt, atomic nuclei are crushed together under unimaginable force. In those moments, elements like gold and platinum are forged, then scattered into space. Every piece of gold on Earth carries the memory of a stellar collision, ancient fire cooled into beauty, resting silently in human hands. Space stretches light as it travels. Light crossing the universe doesn't just move forward. It's stretched by the expanding fabric of space itself. Waves lengthen, colors shift toward red. This cosmological redshift tells astronomers how far and how ancient a galaxy truly is. The light we receive is not just old, it's been gently pulled apart by time and distance, a signal softened by the universe's steady breath. The universe still echoes with ancient sound. Before atoms formed, matter and light were locked together in a hot, dense plasma. In that early state, gravity and pressure created ripples, cosmic sound waves. Though the sound itself faded, its imprint remains frozen in the arrangement of galaxies today. These subtle patterns are fossils of primordial vibrations, echoes from a time when the universe rang like a bell before falling quiet. Galaxies grow by quiet consumption. Over billions of years, larger galaxies slowly absorb smaller ones. Stars are stretched into streams, then blended until no clear boundary remains. The Milky Way bears these scars, faint arcs of stars that once belonged elsewhere. Galactic cannibalism is not violent. It is patient, inevitable. Growth through absorption, leaving only whispers behind. Some stars don't shine steadily, they breathe. Certain stars pulse and flicker with precise rhythm. Their brightness rises and falls like a slow heartbeat. These variable stars act as cosmic clocks, helping astronomers measure distance across vast space. A single repeating flicker can reveal how far away a star truly is. Not all stars simply burn. Some inhale, exhale, and quietly keep time. Black holes can wander without a home. Not every black hole rests at a galaxy's center. Some are ejected during collisions or kicked free by gravitational waves. These rogue black holes drift through space unseen, revealing themselves only when they disturb passing matter. They carry no light, no orbit, only mass and motion, falling forever through darkness. Even stars can become crystals. When stars like our Sun die, their cores remain as white dwarfs, dense spheres often made mostly of carbon. Under extreme pressure, that carbon may crystallize. Some stars may become enormous diamonds, Earth-sized and slowly cooling over billions of years. Once blazing furnaces, now silent jewels glowing faintly with ancient heat. Most of the universe's story is still ahead. Though the cosmos is already billions of years old, its future stretches far longer. Stars are still forming. Galaxies are still assembling. The era of darkness lies far ahead. We live in a brief season of light, a cosmic spring, where motion, creation, and wonder are still possible. The past is vast, but the future is deeper still. Supernovae never truly end. After the initial flash fades, the debris continues expanding for thousands of years. These remnants glow softly across the spectrum, tracing the shape of a star's final breath. Long after the explosion is forgotten, the echo keeps moving outward, a slow exhale written across space. Even planets can bend light. When a planet passes precisely between a distant star and Earth, its gravity can briefly magnify the starlight. This delicate effect reveals worlds otherwise invisible. A tiny curve in brightness, and a hidden planet announces itself without a sound. Once, the universe glowed warm and orange. Before stars and galaxies, all of space was filled with soft light. As atoms formed, that glow faded and stretched into the faint microwave whisper we detect today. But long ago, the entire cosmos shimmered with warmth, a gentle ember cooling into darkness. Some regions of the universe cool more slowly than others. Time, space, and energy do not fade evenly. Even in a universe moving towards stillness, change lingers. And in that lingering, stories remain, waiting quietly to be noticed before sleep finally arrives. As the universe expands, it slowly loses its warmth. Not suddenly, not evenly, but gently, like a great room cooling after the lights have been turned down. Some regions hold onto their heat longer. Places where matter is dense, where light has been trapped, where motion still lingers. Galaxy clusters, filled with glowing gas, can remain warm for billions of years, while quieter regions cool much faster. These small differences shape everything that follows: how stars live, how structures grow, how long change can continue. The universe doesn't cool like a machine following a single curve. It cools like climate: uneven, textured, calm, but never identical. It's possible that new universes could one day be born. Some theories suggest that our universe may not be alone in its creation. Under certain conditions, entirely new universes could bud off from our own, forming through quantum fluctuations, black holes, or processes we don't yet understand. If such a birth were to happen, it would likely be far beyond our reach, invisible to us forever. And yet the idea remains that even in deep cosmic darkness, something new could quietly begin. An opening inside a closing. A beginning folded gently into an ending. The universe still hums with the memory of its birth. In the earliest fraction of a second after the Big Bang, space itself expanded violently in an event called inflation. Tiny quantum ripples were stretched across the cosmos. Those ripples became the seeds of galaxies, stars, and planets. Their imprint still remains. We see it in faint temperature variations in the cosmic microwave background. One day, we may hear it again as primordial gravitational waves, subtle vibrations moving through space-time like the fading tone of a struck bell. The universe may feel quiet now, but it has never fully stopped ringing. The universe is vast, and you are part of how it becomes aware. The atoms that make you, carbon, calcium, iron, were forged inside stars long before Earth existed. They drifted through space, gathered into planets, and eventually into life. You are not separate from the cosmos. You are one of its expressions. A brief moment where matter became capable of noticing itself. In that sense, the universe learned how to look back, to wonder, to imagine. And even as you grow sleepy, that quiet awareness continues. Thank you for sharing this moment of stillness. We've drifted across immense distances, past ancient explosions and silent galaxies, listening to echoes left behind by the beginning of time. And somewhere within all of that motion, there was you, breathing slowly, thoughts softening, perhaps already asleep. The universe holds great energy and mystery, but it also holds rest. And the fact that we can meet it calmly, piece by peaceful piece, is something rare and beautiful. So wherever you are now, awake or drifting beyond thought, may your night be gentle. may your rest be deep. And may you carry with you, even faintly, the feeling of a universe that glows not only above you, but quietly within you. If you're still awake, the next chapter is waiting. And if sleep has already found you, that's perfectly okay too. Good night.